Hello. In this tutorial, we are going to do the full 101 deployment of your application to the Phala Cloud. We're going to take an example from the documentation, not in the tutorials, but in the getting started section. We are going to deploy our own confidential data science and tool. Basically, it's just Jupyter inside of a shell. And we're instead of using the local host through the dstack documentation, which you could always do, we are instead going to do the exact same thing, but with a already made dstack, which is Phala Cloud. So basically, to kind of shorten the time on launching your own IDE, now that VS Code is open source and people want to start learning how to build their own IDE, maybe confidential IDE, right, for code execution or for data science purposes, which is very important. We're going to copy this image because this is just a standard Jupyter notebook, and take note of the port and the port forward, and this is going to run on our TDX, which is going to be ran and executed through Phala. And then we're going to make sure that it can be accessible, so to the actual administrator. And so we instead are going to not use the dstack UI. We are going to not use the monitoring tools of that. Instead, we are going to use Phala's. So we're going to go here, and as you can see, I have my own CVMs, which I've already deployed. So let's basically deploy a new app, and you're going to do the same thing. So you can click Docker Compose, and this is going to create a container for us that's going to be ran inside of the TDX. So we're going to call this Jupyter, right, notebook, IDE, let's say. And since it really is a small image, I don't need to go overload. I can just do a small one. And basically, if I had any kind of encrypted keys, like say if I had like a secret, which I don't, but I can put up like the OX123 here, which is like a key or like a password, right? Like something that needs to be protected in the actual app. You can put it in that here. So instead of making your environment variables exposed, you can basically continue to make them secret as you need them to be. API keys are another example. So you could do all these are basically left on. This is just so that you can do the key management service, so you can transfer ownership. It's also necessary for like a lot of the security promises that TDX is, and also the dstack framework a lot. You also have the public logs so that you can attest to the actual like verifiability of the program, as well as like the environment it's built on, which is the hardware. And then basically making that information public and making sure that you can actually have a proxy, so you can access the channels, and potentially even create a much larger orchestration of agents. So that's what some of these are for. And if you're really trying to do this open source, then obviously do it as a non-private registry, but you always have the option of making, of course, like your own private container, which is what the benefits you get out of Docker and AWS ECR. So say if you have like a Kubernetes instance, and you have many containers and you need those containers to not be moved over to Phala Cloud, you can still run them on Phala and still make their imports and say their dependencies or other kinds of program executions. You can now turn those containers into confidential ones, really bolstering the value of your network. Or you could just do it all private, right? And you can just make everything private and confidential, which is an option. So we're going to deploy the cheaper one, and we're going to do the deploy now. So without all of that, that would have just taken a few seconds. But I figured I'd explain some of this because as it's starting, you can kind of see what I mean. Here are the logs that are going to be available for the public to see, but you can see that it's basically mounting, and it's going to launch varieties of services that the core of dstack offers. So that's going to be the virtual machine, that's going to be the core VMM that's running the actual monitor. So that's how we can see the program. We can also use the KMS here. We can see that we're launching that as well. And then the gateway, so we can wire guard safely between the monitoring and the key store management that is occurring here in this whole setup. So it's a very modular setup. That's why everything has to be deployed one at a time. And also obviously booting up the TDX so that you can run the container, the Docker container inside of the actual port that's running the confidential container instead. So you don't have to necessarily worry about setting up your own TDX. Or it's known as a trusted domain extension. So let's get out of this. That's just some history. Let's go inside of it, right? And I can see that it's using some memory, obviously, and some storage. Great. I can see my app ID, the actual ID of the virtual machine, if I want to like basically delete it or not, and the same logs that basically anybody else could see, as well as the attestation. So like this is the certificate that I could see for checking if whether or not the actual environment itself is what it says that it is. And the program as well. So I can come in here and check on all of that. And if I want to read more, there's a bunch of more information here inside of the attestation tab. There's the composer file, so like my secret hash, effectively, my salt. How does like, anything kind of get encrypted? I can come and see that. And then I think the most important tab is the actual tab where I can go and see the app, running. So I can click on that, and boom, there we go. Like what I just did, I just launched the Jupyter Notebook. So I have some code here that I've been wanting to try out, right? I could show you that this is working. So let's do the notebook, and I have some code that I want to like paste, and it's my own algorithm. So I want to do some data science, and let's just call it like prime selector, right? Because that's what this program does. Now I can come and run it, and this is running inside of a confidential container. So it found some prime number, and I want to enter a new prime number, and let's do what it suggests, which is like what comes after 173, and it should be the number 179, and I get all of these other kinds of oscillators that I'm checking for in my own program. So that's great. Everything is running perfectly fine. I could, of course, obviously run it again and see, what else does it do? I can say 7, and then I should be able to get some random other prime number, which is the whole point of my little program and what I'm running to do. So I can do my own science, my own data science, and do it here safely and confidentially, knowing that no one else is getting access to it. But what's really cool is that we could actually run and deploy this and still be able to execute a complete safe domain, and I can make my own domain that attaches to this IDE. So I can allow others to visit my own Jupyter container, which could have anything on it. So what's really great about this system is that I could maybe be a person who's the only person who can post code, right, to my confidential workload. Or maybe I allow anybody to kind of put their code here. So this is no different than effectively running like a governance or a smart contract system. So I could now do that because the KMS actually attests on chain. So it's great. I can actually see if that the program is running, and I can attest to it via the blockchain through the KMS. So I can see the container. I can see the kind of command that I want to be able to use to access that container. Again, it was running a Docker compose file. I can view what that file was again, and this is the same one from the tutorial. And then other event logs. It's not totally important unless you're needing to transfer ownership, which is very important. So I can actually check on the events of the actual application here in the cloud, and there's a whole bunch of other services that Phala offers, which is really handy. So I could do the danger application thing. So if I need to transfer something to somebody, I can do that too. So yeah. Anyway, there is a bunch of other things, and I'm not going to go into every single detail, but just like I could do it again and again, I can keep launching a bunch of applications, and then I can, of course, come to my bill and the support section and go and check on all of the other price options. And if you're looking to do something that's like way more custom, obviously you can come and do that here. But the pricing is actually pretty moderate. There's a free tier, which is really useful, so you can just get trying it out. But you could also just do the one that I'm using, which is like getting out the actual domain and stuff, and just running your own applications in the cloud. And it's a really easy way for just like launching an app with your own domain, right? Like this, I can launch this entire site, for example, and like just have it hosted through my own domain, and then just have the DNS record point to this, right? So I hope this gave you a better understanding of kind of what you're reading. Please, obviously come in here and check the documentation. You can always get started here at the DStack docs. But it's really useful to kind of use this as sort of a way to understand how Phala Cloud works. And I hope this video is helpful for you to know how to launch and deploy your own Docker containers and applications to Phala Cloud. So thanks so much, guys. Bye-bye.